You're listening to the N2K Space Network.
Cyber threats are more sophisticated than ever. Passwords, they're outdated and can be cracked in a minute. Cyber criminals are intercepting SMS codes and bypassing authentication apps. While businesses invest in network security, they often overlook the front door, the login. Yubico believes the future is passwordless. YubiKeys offer unparalleled protection against phishing for individuals, SMBs, and enterprises. They deliver a fast, frictionless experience that users love. Yubico is offering N2K followers a limited buy one, get one offer. Visit yubico.com/N2K to unlock this deal. That's YUBICO. Say no to modern cyber threats. Upgrade your security today.
When spacecraft are sent to space, they currently have to carry all of the fuel to power them for their entire mission. Once that energy runs out, the mission ends. But what if there's a solution to that space conundrum? Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Starcatcher is creating the first energy grid for space. They're developing orbital infrastructure that they say will transform how satellites are powered.
I'm Andrew Rush. I am the president, CEO, and co-founder of Starcatcher. I have basically always been obsessed and wanting to work in the space sector, to enable people to do more stuff in space, enable them to do cooler stuff in space. I was raised on a pretty steady diet of science fiction and science fact. Grew up watching Star Trek, and my mom was a physics and chemistry teacher. My father's a chemical engineer. So, this is kind of where I was destined to wind up, despite taking a little bit of a detour and being a patent lawyer for a couple of years.
Oh.
Yeah, I much to my parents' temporary chagrin, I got into grad school for physics after doing an undergrad, and then decided to go be a patent lawyer for a while because it was this cool mix of entrepreneurship and technology. Really worked in the space sector, worked for space companies with my practice, and then became the CEO of Made in Space, which was founded in 2010. It was the first company to do manufacturing off the face of the planet. And we did a ton of work with NASA and DARPA and Air Force and Space Force on satellites that manufacture and assemble themselves in space, because we felt that manufacturing in space is this incredibly transformational technology, right? Like, you're going to build starships in space, not on the ground. You're going to, and there are all of these awesome industries that, taking gravity out of the manufacturing equation enables. And it's really exciting to see, after we bootstrapped that company and sold it successfully, that there are multiple, generations of companies really that are leveraging now the additional financial tools that exist for the space sector to move that ball forward, commercialize and industrialize LEO and beyond. From there, I became the president and chief operating officer of Redwire, which is now, a unicorn, publicly traded space subsystems and components provider, about to become a really differentiated and awesome, space and defense tech firm by combining with another really cool company. At Redwire, we built at the time the largest independent provider of solar arrays and space structures in the United States. And, put new solar arrays on the space station, did a lot of work for DoD, did a lot of work for commercial companies in that arena. And I've always felt, when designing a space mission, you're focused on SWAP, size, weight, and power. And for a lot of us, the aperture has opened up on the size and weight portion of that equation because of reusable rockets and launch costs coming way down, because of Falcon 9 because of Electron and now New Glenn and Starship and and Stokes vehicles and all these things that are coming online. It's really, really amazing. And they're really building the roads to space, like that sort of transportation infrastructure. But power is still done in this like camping trip kind of mentality. We take our solar arrays with you, and you gotta build to that. And if you don't have enough power, which spoiler alert on basically every space mission I've ever been involved with, we're power limited. You're kind of out of luck. And so that really motivated us to start Starcatcher to build a power grid in space, to build the power infrastructure to go alongside the transportation infrastructure that SpaceX and others are building to enable us to commercialize and industrialize and settle and explore the stars.
That's awesome. Your journey is fantastic, and I just a huge fan of Redwire. Also, I've spoken with them in the past, and big admirer of their work. So, and I'm also really fascinated by that law and physics coming together background, because that had to have given you such a fascinating insight, and so much in space overlaps in that way. But a lot of people don't have that specialized knowledge, but you do. So that's really cool. I imagine that's come in handy quite a bit in what you do.
Yeah. It was a little bit worrying the first semester in law school, because I was like, oh, there's all these English majors, they're really good at writing, and I just have this physics background. But it turned out to be
just physics. I'm sorry, my dad was a physics professor, so I'm like, just physics.
Well, it turned out to be really useful, because at the end of the day, like thinking like a lawyer, or like the process you use to build good arguments as a lawyer is really just the scientific method. But you don't have like the immutable laws of the universe that you're applying. It's like these great, federal, state, local, human written documents. But
the bounds are different.
Right, the boundaries are different. Yeah. And so it was, so actually the technical background I felt was really useful as a lawyer, and you're right, like having the kind of marriage of that. Not only has helped me reduce legal fees for the companies I've worked at, but also, helps us build things.
Yeah, I would imagine, especially at your level, being able to present the persuasive arguments and that kind of thing is extremely important. Doing what you do. I'd love to get a bit more into also the company that you're building. You mentioned earlier being a Trekkie. I'm also a Trekkie, so the thought of like providing more power to the engines is like the most Trekkie thing I can possibly think of. So it's really cool that is what you are working on. So tell me a bit. Let's go into a little bit of detail about what you all are building and how it's different from how I've talked to people about like space-based solar power, but what you all are doing is not to ground, but to other. So let's get into that.
Yeah. So at Starcatcher, we are building the world's first power grid in and for space. We're building a constellation of satellites that collect, concentrate, and redirect solar energy to our client satellites' existing solar arrays to give them more power, higher concentrations of power in eclipse. Some really important key tenets for how we're building this power grid in space and operating is we want our customers to have to retrofit as little as possible. And what that means is we're not selling. They don't need a custom receiver to work with us. Everybody has solar arrays on their spacecraft already. Solar arrays are these awesome band gap semiconductors that if you send them, photons in the kind of 400 to 1100 nanometer regime, they're going to take those photons and readily convert them into power at really high efficiencies, depending on who you're getting your solar cells from. And if you increase the flux, like the amount of photons you're sending to them, you'll generate in a relatively linear way additional power. So what does that mean? That means if I take a solar array that in LEO generates 400 watts per square meter or something like that. And if I give it 5 suns of what it's seeing in LEO, it'll generate 5 times that amount of wattage, 5 times that amount of power. Folks have shown this, and we've experimented with this in the lab. That you can get up to like 30 or 40 suns of additional power. And this is in effect in practice. The Bepi-Colombo probe that is at Mercury today sees 12 times the flux that you see in LEO, and it uses just off-the-shelf Azure PV and generates about 12 times the power with those solar arrays. So that enables us, if we're sending energy in those regimes, to just use the existing solar arrays that customers have to give them more power. We also don't.
Can I stop you for a quick second, just so I can understand? I'm sorry, you're on a roll, and I'm so sorry. I want to better understand. I guess the problem that, because this is genuinely, I know very little about this, so this is mainly for my edification. So what is preventing satellites currently in orbit from getting maybe the most out of their solar arrays? Is it just alignment? And also, is there an upper bound? I mean, for lack of a better term, we don't want to fry the arrays, right? So is there like an established upper bound for how much power they can receive? Okay, those are my 2 questions.
No, those are great questions. And so a pretty standard approach to designing a space mission is that you say, well, I want to, here's the value I want to provide, or here's the mission I want to fulfill. And what are the components I need to buy and integrate together in order to fulfill that? And if we all had infinite money, we would make custom things for every single mission. You'd never be power, thermal, or communications limited. And we'd also just spend ourselves, out of house and home. So the reality is, we go to companies that make like predefined satellite buses. And make really quality products so that they've already done the NRE on, and we can buy them in like incremental ways. But most of those buses will come, especially like low Earth orbit focused, like ESPA class buses. They produce on average like 800 to like 1500 watts of power. And that's if you're like always kind of keeping your solar arrays at the sun. So if you're doing maneuvers, or if you need to prioritize your payload pointing, that reduces the amount of power available.
Right. Yep. Okay.
And for some missions, that's enough power. But we live in an era now where we want to do a lot more with our spacecraft than we wanted to do even 5 or 10 years ago. We want to do direct-to-device cell phone connectivity, which requires a lot of power. We want to do edge computing with the latest, like off-the-shelf NVIDIA GPUs or TPUs and all that kind of stuff. And those things are not designed to sit, tens of watts. They want 100 watts or more, or lots. My kids' gaming computers at home would eat up the entire power budget of a given ESPA class satellite that you buy off the shelf. So, and not, to say nothing of like the electronic warfare missions and maneuver without regret that we'd like to do from a national security perspective.
We'll be right back.
And now, a brief message from our sponsor, DropZone AI. Is your SOC drowning in alerts, with legitimate threats sitting in queues for hours or even days? The latest SANS SOC survey report reveals alert fatigue and limited automation are SOC teams' greatest barriers. DropZone AI, recognized by Gartner as a cool vendor, directly addresses these challenges through autonomous recursive reasoning investigations, quickly eliminating false positives, enriching context, and enabling analysts to prioritize real incidents faster. Take control of your alerts and investigations with DropZone AI. Tired of investigation tools that only do one thing at a time? Spending more time juggling contracts with data vendors than actually investigating? Maltego changes that for good. Get one investigation platform, one bill to pay, and all the data you need in one place. It comes with curated data and a full suite of tools to handle any digital investigation. Connect the dots so fast, cybercriminals won't even have time to Google what Maltego is. See the platform in action at maltego.com.
So we basically have this kind of supply and demand gap for power generation in space. That the way we've architected spacecraft so far, the way we traditionally build spacecraft, leads to duty cycling. Because we don't have enough power generation on board, that we on board of the satellite. So we charge up batteries with our solar arrays, and then we use that stored energy to operate our payload, but not at 100% uptime. And then there's a whole other area of like life extension. We design satellites for end of life power generation estimates, but we also thought, but really we can use the beginning of life, and end of life is 30-40% less than beginning of life. We can fill that gap with providing additional energy and extending the life of the spacecraft. We can also fill the gap between what you want your spacecraft to be at from a power perspective and where it is just natively with just the one sun. So those are a lot of the kind of value propositions of why. In addition to, there's a big cost savings in using a small platform satellite and sending power to it versus just building a satellite with bigger solar arrays. Because when you do that, you get into this sort of engineering, systems engineering doom loop where you're sizing up the solar arrays, and then you're sizing up the reaction wheels, and then you're sizing up the satellite bus, and all of a sudden, and that increases launch costs. All of a sudden, you're going from some nice, cute little square meter ESPA class satellite to a cake topper or a totally dedicated launch kind of sub.
Yep. And then, of course, if the solar array doesn't unfurl, for lack of a better term, in the way that it should, then you have a really big problem.
Yeah. And that's actually another area where we can help, right? Like, solar arrays have this great inherent property that I could, they'll readily convert more energy if you send more energy to it. Where you have missions, like a lot of these kind of, orbital transfer vehicle folks, like sometimes one of the arrays won't pop out. And so they have to just like instantly deploy, their client satellites in orbits maybe they didn't want, or with spin that they didn't want, because the spacecraft's going to die. It's going to run out of power and die. Like, when our network is online, those folks can just call us up and say, hey, Starcatcher, please send additional flux to the spacecraft so we can keep it power positive, we can assess what's going on, and we can save the mission for ourselves and for our customers.
I could see that being an absolutely transformative, very transformative to the industry as it is right now, which is a really interesting thing to hear, because sometimes when I talk to some people who are building businesses, it's like we're getting ready for something 10 to 20 years from now, but this would be useful for really right now. So what a really cool thing that you're building. Sorry for nerding out, but I'm like, that's really cool. That makes a lot of sense.
No, I appreciate it.
Yeah. No. So let's. Can you talk a little bit about maybe timelines for the development for what you're all working on?
Yeah. So we announced the company and our initial seed round fundraise last July. It was $12.3 million, led by some really amazing capital partners that are really, really, a lot of experience in helping people build great businesses, as well as a lot of experience and knowledge in the space sector in particular. Since that time, we have started to do a lot of really amazing in the laboratory demonstrations. We've built up a team where we've gone from 3 folks to over 30 folks. Almost all of which are engineers and technicians, doing the things that they do really well. It's like me and a couple of folks who's, where our jobs are basically to keep them in good facilities and keep their CAD licenses up to date so that we can build awesome things.
That's awesome. Yep.
For 2025, we have a series of ground demonstrations that we're going to, more and more complex and ambitious ground demonstrations that we're going to do and then talk about publicly as we kind of hit some major milestones. And then, leading up to both fully integrated, receive sunlight, condition it, beam that, multiple kilometers, multi-kilometer distances at really, meaningful power levels to mock satellites in the ground. And then all that technology will fold into a first space demonstration in 2026. Exciting.
And I saw also just recently you all got an AFWERX SBIR Phase 1 award. Congratulations. I was just looking at my notes. I'm like, that's great. That's a wonderful validation for your mission.
Yeah, thanks so much. Yeah, no, we're really excited and proud to be partnering with AFWERX, with the DoD, to have that first win, and really show folks like, hey, in that deep way that you do with those sorts of customers, how this can be enabling, transformational for current and future missions, and provide additional resiliency and protection for the warfighter's mission.
That's fantastic. Well, again, congratulations. That is really wonderful news for you all. All right, so I'm very interested in hearing sort of a bit about how you manage, what your day is like. I think a lot of people want to be in your shoes, so it's sort of an interesting view into your world. So, if I could ask, like, what is the best part of your workday, and what is the hardest part?
That's a great question. Because I occasionally get to talk to people about it, and especially other kind of first time CEOs. And the thing that I tell people a lot is like, look, this is a very emotionally up and down role, and like you can really sort of get like slapped in the face at breakfast, and then get like patted on the back at lunch, and then get kicked in the shins at dinner, and then rinse and repeat the next day. And I think that a lot of my role is to enable the team to be set up for success in the face of all those things. Because you get a lot of no's especially as like an early startup. Like, you get a lot of no's, you get a lot of like, hey, what about this, or what about that, or are you sure? And then really it's just kind of overcoming objections and pushing really hard pushing hard until things start to really sort of run smoother. And all the while, like, just kind of being that sort of guiding line of that lighthouse for the team, so that we can execute together on and take the vision that we have and turn it into reality. So, and honestly, like, the best, it sounds a little bit cheesy, but like the best parts of the job, of the role, are like seeing people do that, like seeing them go from like, hey, we have this idea, to, hey, look, like, there's this little mock satellite over here, like, across the lab, that's on a track that we're beaming energy to completely autonomously, and it's moving around and doing stuff. I'm like, that's really awesome. And then the hardest parts are, you gotta, or the other pieces, and you have to, I feel like you have to kind of be that lighthouse, or that rock, so that you can create the space for folks to do really cool things in the lab and outside, in space.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I'm your host, Maria Vermazes. Thanks for listening. We will see you next time.
Cyber threats are evolving every second, and staying ahead is more than just a challenge, it's a necessity. That's why we're thrilled to partner with ThreatLocker, the cybersecurity solution trusted by businesses worldwide. ThreatLocker is a full suite of solutions designed to give you total control, stopping unauthorized applications, securing sensitive data, and ensuring your organization runs smoothly and securely. Visit threatlocker.com today to see how a default deny approach can keep your company safe and compliant.